Hey, it's Mr. Estrada, and our aim for this video is how do we solve problems that involve inscribed angles and angles inside and outside of circles. Okay, so here's a little warm-up. I want you to find the measure of the central angle labeled x, and I want you to assume that all three angles are equal. So I'm going to label this x, and I want you to find the value of x, assuming that all central angles are equal. Okay, so since all these angles here form a circle and they are all equal, we can just take 360 divided by 3 and we will get the value of x. 360 divided by 3, that's 120, so x is 120. Alright, so central angles and inscribed angles, what's the difference? So here's a central angle, and we just saw one from the warm-up. In a central angle, the vertex of the angle is at the center. Is at the center of the circle. Here's an inscribed angle. And in an inscribed angle, the vertex, so the vertex here is S, the vertex is on the circle. So in a central angle, the vertex is at the center of the circle, and in an inscribed angle, the vertex is on the circle. So you see point S, the vertex of angle RST, is on the circle, and that's the difference between a central angle and an inscribed angle. In a central angle, the intercepting arc, so let me give these points some names and I'll tell you what I mean by arc. Okay, so angle C is a central angle, and the measure of the central angle is equal to the intercepting arc. So here's arc AB. So you could think of arc AB as the crust on a pizza pie. So in a central angle, the measure of the central angle is equal to the measure of the arc. Whereas in an inscribed angle, that is not the case. So let's look at inscribed angles. An inscribed angle is half of its intercepted arc. So angle B is half of arc AC. So here's angle B. This is the intercepting arc of angle B. That's the arc that the angle intercepts. And angle B is half of arc AC. In general, we can write the formula this way. An inscribed angle is equal to the intercepted arc divided by 2. So just suppose for a minute that the measure of arc AC is 80 degrees. What would be the measure of angle B? Well, that would be 80 divided by 2. Angle B would measure 40 degrees. Let's look at another example. Find the value of B. Okay, well, what do we know? Well, B is an inscribed angle. It's an inscribed angle. Therefore, B has to be half of the intercepting arc. It has to be half of arc AC or CA. So that's arc AC divided by 2. But now we don't know what the measure of this arc is. So is there a way that we can find it? Well, here's what we know. We know that the whole circle is 360 degrees. And we know that the measure of arc AB is 60 degrees, and we know the measure of arc BC is 82 degrees. If the whole circle is 360, what must be the measure of arc AC? Well, let's write down what we know. We know arc AB plus arc BC plus arc AC. We know that all those three arcs must add up to 360 degrees. So arc AB, 60, arc BC is 82. What must be the measurement of arc AC if all these three arcs add up to 360? Well, let's do the math. 60 plus 82, that's 142. So these two arcs added up together, it's 142. 360, take away 142, gives us 218. So arc AC is 218. And if arc AC is 218, then that means that B, which is what we're looking for, is 218 divided by 2. 218 divided by 2 is 109, so the answer is 109 degrees. All right. We also have another formula that involves angles formed inside the circle. So here, the vertex is inside the circle. And what's the relationship between the intercepting arcs and the angle when the angle is inside the circle? The relationship is that the angle inside the circle is equal to the sum of the intercepted arcs divided by 2. Or we could say it's half the sum of the intercepted arcs. Another way we could write it is we can call these things, sometimes they'll call them the major intercepted arc, and they'll call this the minor intercepted arc, and the formula is written: the angle inside is equal to the major intercepted arc plus the minor intercepting arc divided by 2. It's just another way to look at the formula. But essentially they're saying the same thing. They're saying, look, when the angle's inside the circle, it's equal to half the sum of the intercepted arcs. Okay, so here's an example that uses that formula. In the diagram below, circle O, chords AE and DC intersect at point B, such that the measure of arc AC is 36 and the measure of arc DE is 20. What is the measure of angle ABC? I'm going to label this X, because that's what we're looking for. Well, what do we know about angle ABC, or X as I'm calling it? Well, we know it's inside the circle. When the angle is inside the circle, we know that the angle inside the circle is equal to, that's my angle sign. Let me rewrite that. Didn't look quite right. Is equal to the major intercepted arc plus the minor intercepted arc divided by 2. So now we just have to substitute. So here's the major intercepted arc, that's 36, and here's the minor intercepted arc, that's 20. Add those two up, then divide them by 2. 36 plus 20, that's 56. 56 divided by 2, that is 28. So x is 28, which means that angle ABC is 28 degrees. So when the angle's inside the circle, all we have to do is add the intercepted arcs and divide them by 2, and we get the measurement of the angle inside the circle. Okay, now we have another formula for when the angle is outside of the circle. And that can happen in any of these three cases. That could happen with two secants. That could happen with a tangent and a secant, or that can happen with two tangents. So what's the relationship here? Well, here, the angle outside is equal to half of the difference of the measures of the intercepted arcs. So here we are subtracting the minor arc from the major arc and then dividing the result by 2. So one way we could write it is we could write them like this. We could label the major arc x and the minor arc y, and we could say x minus y divided by 2 gives us the angle outside. Or we can just use the other labelings that I had used earlier. We can call this major arc. This would be the minor arc. Major, minor, major, and this is minor. Intercepted arc. And then the formula is just angle 1, which is the angle outside, is equal to the major arc minus the minor arc divided by 2. So let's look at an example. In the accompanying diagram, PQ is tangent to circle O, and PRT is a secant. If the measure of angle P is 56, and the measure of arc QT is 192, find the measure of arc QR. So I'm going to label this X. Alright, this time I'm given an angle and an arc, a major arc, and I'm looking for the minor arc. So the angle's outside, so I know that I'm going to be dealing with the formula we just looked at when the angle's outside. So let me just write angle outside. So, well, what does the formula say when the angle's outside? Well, the outside angle is equal to the major arc minus the minor arc divided by 2. Well, we know that the angle is 56. We know that the major arc is 192. We don't know what the minor arc is. We labeled that X. So here's how I'm going to substitute. I'm going to write 56 because the angle's not unknown. I know what that is already. So it's going to be 56 equals the major arc, which is 192, minus the minor arc, which I labeled X, divided by 2. So this is how my equation should look when I substitute. So now I have to solve this. So here's how I'm going to solve. If you recall, I can put the 56 over the 1. I have a fraction equal to another fraction. I can cross multiply to solve for x. So let's briefly go over that. So it's going to be 192 minus x times 1. Anything times 1 is itself. So that's 192 minus x equals, and then we got 56 times 2. What's 56 times 2? That's 112. Now you solve for x. Minus 192. Don't panic just yet. because you got a negative here, because we still have to divide both sides by -1 since the coefficient here is -1. And we're going to get x equals 80. If x is 80, what that means is that arc QR is 80 degrees. Okay, I hope this video helps you get an idea of how to use these formulas. Click on the links below the video so you can get some more practice using each of the formulas. I hope this video helps. Take care.